Hey everyone, welcome back to Cracking the GRE Subject Test. This is Calculus 2 and we're on question number 21. So in this question, we are given an equation for a surface. There it is. And we're asked to find which of the vectors is normal to the surface at the point where y equals 8 and z equals 4. Well, what we have to do here is to think about this surface as a level surface of the function f of x, y, z equals log of x plus y squared minus z cubed minus x. It's the level surface where y equals 8 and z equals 4, and we should also figure out what x is because we're going to need that. Let's see, what would x be when y equals 8 and z equals 4? That means that we have a log of x plus 64 minus 64 equals x minus 1. Well, 64 and 64 just cancel out, so we get log of x minus x equals negative 1. Well, if you kind of look at this and try out some different numbers, you can figure out that x is equal to 1 because log of 1 is 0, minus 1 is equal to negative 1. Okay, so now we know what x is. So in order to find the vector that is normal to this surface, then we're going to need to figure out what the gradient of f is. Remember, the gradient gives us the normal vector. So let's take the gradient of f. Remember, that's going to be a vector whose elements are the partial derivatives of f with respect to x, y, and z, respectively. So the first element here is going to be the derivative of log of that whole thing minus x with respect to x. So that's going to be 1 over x plus y squared minus z cubed and minus 1. Our second element is again going to be 1 over x plus y squared minus z cubed. But we're going to have to use the chain rule and multiply by 2y. So I'm going to put 2y up here. And our third element is going to be 1 over x plus y squared minus z cubed. And then the chain rule is going to give us a negative 3z squared up top. And we have to evaluate this at the point where x is 1, y is 8, and z is 4. So let's see what that gets us. Here we're going to have 1 over 1 plus 64 minus 64. So actually, the denominator in each of these is always going to be just 1. And here we have 1 over 1 minus 1, so this whole thing is going to be 0. That's right, equals 0. Okay, the second element is going to be 2 times 8, that's 16 over 1, so that's just 16. And our final element is going to be negative 3 times 4 squared. Well, 16 times 3 is 48, so that's going to be a negative 48 over 1. So that's going to be a negative 48. Okay, well that's not any of these answers, but any vector in the same direction, in other words, any scalar multiple of this vector is also going to work. So if we factor out a 16, we'll get 0, 1, negative 3, which is j minus 3k, or answer E.